Welcome back to Learning with Ms. H. Today we are going to start our Earth, Moon, Sun section of astronomy. We're going to be looking at part 1 of the Earth, Moon, and Sun, which is the motion of the Earth and the Moon. Your bell work today is to think back to what you learned about astronomy and write down what you can remember about why ancient civilizations built structures that aligned with the sun. What was the purpose of that? The second part of that is think about what that might have to do with today's lesson, knowing that we're going to be talking about the motion of the Earth and the Moon today. Next time we will include the sun in that motion. So answer that, pause this video, gather up what you need to write with and on for the notes, come back and restart the video. All right, welcome back. We've got notes and then a couple of assignments, one super short and one a little bit longer. But let's go ahead and jump into the notes first off, because you're going to probably need some explanation for at least one of the homework assignments. So Earth, Moon, and Sun. We have an Earth, Moon, Sun system that functions together to do all kinds of different things for us. So what we're going to start off with today is the motion of the Earth. You've got some vocabulary listed here. These are terms that you'll see in today's notes. Please pay attention to those when they come up. Make sure that you double check your vocabulary page and that you've got them on there correctly. So, motion of the Earth. We have two different types of motion, rotation and revolution. Rotation is what happens on our axis. We have that axis that is an invisible pole that goes straight through from top to bottom of the Earth, North Pole to South Pole. And it's actually tilted a little bit, but the Earth basically rotates on that axis. It just spins in a circle like a top. This is what gives us our day. The solar day goes from noon to noon. It's about a 24-hour period, roughly. 23 hours and 56 minutes is how long it takes to rotate. And that's why the amount of daylight that we see each day changes just a little bit. And that's how we end up with daylight savings time coming into account and that kind of thing, because people were trying to eke out as much daylight as they could during their hours they were awake. So the second type of rotation, or of motion, is revolution. We've talked about rotation. Type number 2 is revolution. To revolve is to go around something. So rotate, you spin on an axis. Revolution, you revolve in a circle around something. So we are revolving around our sun. That means we're moving around the sun. Our orbit around the sun is slightly elliptical, and it takes 365.25 days, which is how we get our year. That 0.25 on the end of it is why we end up with a leap year every 4 years. You have a quarter of a day. Every 4 years, that adds up to adding a full day onto the calendar. So that's how we end up with a leap year. We're basically fixing our time so that we're back in the right place. As always, if I am going through this too quickly for you, pause the video in between slides so you can catch up, get things written down, digest the information, and then turn the video back on to pick up where we left off. So we talked about Earth being tilted on its axis. Normally, our North Pole you would think would be directly to the north, where this dotted line is, but our true north is actually a little bit off to the right of that 90-degree line. So we are tilted 23.5 degrees. That's actually not 100% correct since Japan had that giant earthquake several years back, but it's pretty close. And that is still the accepted value for our actual north in science. So we are 23.5 degrees tilted from what would appear to be true north. So we are basically rotating as we revolve, and our hemispheres, one of them is always going to be facing towards the sun while the other one is pointed away from the sun. So if the sun is over here on the left-hand side with the rays coming in, which is what it appears to be because this is lighter, you have the bottom half of the globe is tilted towards the sun while the top half tilts away. That tilt is what causes our seasons. So we are revolving around the sun, and as we revolve around the sun, a different section of the globe is pointed towards the sun. So they're getting more direct rays, and that's what causes the seasons. So you have the northern hemisphere is pointed away, it's winter. Southern hemisphere is pointed towards, it's summer. And then those are going to flip-flop when it gets around to the other side because the opposite end will be pointed closer to the sun. One of the common misconceptions is that the seasons are caused from getting closer or further away from the sun, and that's just not the case. It is solely reliant upon the tilt and where the tilt is in the orbit, as far as which end, top or bottom, is closest to the sun. So, in the wintertime, you're going to have sunlight spread over a larger area. It's less direct because it is tilted away. And in the summertime, sunlight is concentrated in a very small area. So if you take a look at this image, you can see that there's very direct, straight-on sunlight hitting the southern hemisphere here that is angled closer to the sun. And then the northern hemisphere is angled away, so it is more indirect light. As we revolve around the sun, you'll see that our angle of our axis does not change. So this blue line that shows our north and south, our axis, is in the same position no matter where we're at. So while we are spinning, that axis stays the same. So right here, you have the northern hemisphere up here, the southern hemisphere down here. Neither is directly closer to the sun. The northern hemisphere is a little bit closer. On the opposite side, the southern hemisphere is a little bit closer, but again, not directly aimed at the sun. So those are going to be our fall and spring. Excuse me. If you look to the right and left, you have on the left, the northern hemisphere is directly aimed towards the sun. The southern hemisphere is more aimed away. And then on the right, you have the opposite. The northern hemisphere is aimed further, and the southern hemisphere is aimed towards it. So that is your summer and winter. The axis does not change positions. It stays the same in relation to the sun. It's just how we move around the sun that determines which area of the globe is getting more direct light. And that is because of the axis tilt. So when we hit these 4 key points in our orbit, we have names for these days. You probably have heard of them before. You have a solstice and you have an equinox. A solstice is when you are the longest and shortest day. So when you are angled closest to the sun or angled furthest away from the sun, those are going to be summer and winter solstices. So over here, the north is having summer solstice, the south is having the winter solstice, and then you have the opposite here. The equinox, you're going to have as close to even of a day and night as you can. So 12 hours day, 12 hours of night. And those are going to be your fall and spring. And fall is also called the autumnal because it's autumn. When you have a summer solstice, like over here, the northern hemisphere is having summer solstice, that's the longest day. The winter solstice is the shortest day. And same over here, winter is the shortest day, summer is the longest day. So long and short on the right and left, the top and bottom are going to be your as close to equal as you're going to get for night and day. You do need to know the solstices and equinoxes for your homework assignment. They will also be on the test. Okay, so solstice. Sol means sun. Sister means to stand still. So solstice, you have longest and shortest day. It happens twice a year. Longest day is your summer solstice. Shortest day is your winter solstice. And it's the official start of summer and winter, even though we consider the start of summer and winter to have happened before that. This is the official astronomical start of summer and winter. And it's because of those day lengths. And you'll notice when one hemisphere is having their longest day, the other hemisphere is having their shortest. An equinox, aquas is equal, nox is night, so equal nights. You've got approximately equal amounts of day and night. It is, again, the fall and spring, so the autumnal and the vernal equinox. Even days and nights happens twice a year again. When one hemisphere is having spring, the other hemisphere is having fall. You, again, do need to know this information, so make sure you're getting this down. Remember, when you're drawing, you can just do sketches. I do stick figure people. So just get it down, get it sketched out, and if you really want it to be pretty, you can come back later and fill it in. So this is what it looks like on Earth. This location, you can see this hillside here. This is all one long panoramic image that could be used, except it was taken in this exact spot at 3 different times of the year. So it was taken at first in the summer solstice when the sun is just over this mountain over here, and all of this over here would just be the same color of sky as this. Then for the equinox, the sun is in the middle on this mid-rise here, and you can see that it's coming up right in between those two buildings that were built there. And again, the rest of the image would have this peachish, orangish hue to it if you were just looking at the picture of the equinox. The winter solstice, the sky is more of a white than a gray. This has a lot more color in the summer solstice. But you can see that the sun has now moved, so as it came up over this hill in the summer, it's now coming up over this hill in the winter time. So these are 3 different time snaps of the exact same section of hillside. So when ancient civilizations used to mark the passing of the sun with their structures, it was so they could tell what time of year it was and when they were starting summer, starting winter, in the middle of spring or fall. Or in the middle of the year, starting spring or fall. So they would use the sun to mark time so they could know when important ceremonies needed to take place, when harvests needed to take place, those kinds of things. There's all kinds of reasons that they did this. Those were two of um, the more major reasons. All right, so we're going to go ahead and move on to the moon in motion, and we're going to start looking at phases of the moon and how it moves around the Earth. It's known as being tidally locked. That means the same side of the moon is always facing the Earth. We never see the far side of the moon. We have the same side facing us at all times. The shadows are because of where the sun hits it. The sun is always hitting from the same direction here. So the shadow is moving based on where the sun's rays are coming in from. So they're always coming in from the right. And whereas Earth spins on its axis, so we get day and night, the moon does not. So one side is always facing the sun, one side's always facing away from the sun, and the shadow moves slightly depending on where it is in its path. But there's a light side of the moon and a dark side of the moon because of that. So this side of the moon on the back never really gets any light. Because of this, we end up getting phases in the moon. The reason you only have one side facing the sun is because the rotation of the moon matches its revolution around us. So while we go in a circle around the sun, the moon goes in a circle around us. We're spinning much faster than we're rotating, or than we're revolving, sorry. The moon is rotating and revolving at the same speed. So because of this and the dark side of the moon over there, we get phases in our moon. So we see different pieces of the moon on different days. It doesn't have any light of its own, so it can only reflect sunlight. So depending on where it is in relation to the Earth, it's either reflecting full rays or partial rays based on where it is in that path. So we're going to talk about the phases of the moon, and those are the different shapes of the light part that we can see from Earth. Remember, we always see the same side. It's the light side of the moon. We call the other side the dark side because we never see it. So here are the phases. If the sunlight's coming in from the right, you have Earth, Earth in the middle here. So as the moon travels around the Earth, the light that we see as we face that same side of the moon, remember this is the same side of the moon every time we look at it here. If you think of it as a backwards clock, you'd have 12 o'clock, 6 o'clock, and it's going backwards. We're still seeing the same side of the moon here. We're just seeing a different amount of it. It's always getting sun from the same direction, so that's why that shadow moves. So if we start off here at the 9 o'clock position, it's getting full-on rays from the sun. It's coming through and hitting that moon direct on. You get full-on sunlight. That is going to be a full moon. So the middle is the path. The outside ring shows us what our view is from Earth. So we're essentially looking at a top-down view of Earth and the moon, and then a front-on view of the moon on this outer ring. So at 9 o'clock in position here, we're seeing a full moon. So this side that is fully lit up is reflecting sunlight on the whole surface that we can see. Over here at 3 o'clock, the sun's rays are hitting the back side of the moon, the side we don't see. So that would be a full moon. I'm sorry, a new moon. Goodness. Full moon over here where it's lit up, a new moon over here where it's completely dark. And then each of the phases in between, we get a different amount of light that we can see. If it is waxing, then the visible part that's lit up is getting larger. And that's going from new moon to full moon. It's called waxing because the piece that is lit up is getting larger. If it is waning, it's getting smaller. To wane means to shrink. So going from full to new, it is waning because you see a little bit less lit up in each phase. You will need to know the phases of the moon. So I would jot down this picture, just sketch it. You can, go ahead and shade in the pieces that are dark for each one of these phases. And I would sketch this whole image on the right, including the sunlight and the close-up of the view of each phase from Earth. Lunar motion. A lunar month is going to go from new moon to new moon. So how long does it take to get from one new moon to the next? That's a month long. It takes about 29 and a half days. So the month to go from new moon to new moon is 29 and a half. It actually only takes 27.3 days for it to travel around the Earth, which is why we have a new moon not once a month. Our months are generally 30 to 31 days, so we'll have some months where, we'll have 2 new moons in it. So 27.3 days to go around the Earth. It takes 29 and a half to go from new moon to new moon. So we also may have some months where you don't see a new moon. The reason that we have this discrepancy is because while the moon is moving, the Earth is moving as well. So as the Earth is moving around the sun, the moon moves around the Earth. That causes this discrepancy here. So the 29 and a half days, if we're not in a leap year, February is only going to have 28 days. Depending on how the calendar falls that year, you may not see a new moon in February. You might see more than one new moon on a different month. Well, wrong button. That is the end of our notes for the day. So we're going to go ahead and take a look at the homework assignment. Let's do this. Homework assignment. I'm going to right-click it. The first one is going to be a quiz. Not really a quiz. It's a worksheet. It's going to be matching and multiple select. So you're going to choose all of the correct answers. So there are 2 points possible for number 1. The longest day of the year is. Choose 2 of these that are correct. Is it a solstice or an equinox? And then when does it happen? Summer, autumnal, spring, or winter. Same thing for the shortest day of the year. And then down here you've got rotation. Match it to its effect. Rotation causes what? A year, day and night, or seasons. Same thing for revolution and tilt. And then you have 3 points down here for the days of the year is or are. That should be the shortest days of the year. Did I do? Nope, this is equal. This will be equal days of the year. I'll fix that. So the equal days of the year is or are, and then choose the correct responses. Once you've done that, you'll come back here, and we're going to go down here to the moon phase hunt. So open this one, and you'll see the instructions for the moon phase hunt. So you should be able to identify the moon phases by position of the moon compared to the Earth and Sun. Document your findings in a slide presentation format. So you are going to go in and create a Google Slides presentation. You'll go to this website, which we'll go through in a second. You'll follow these instructions on the website, and then this is what your assignment is. So you're going to put your name on the title slide, and then use the simulator up here to align the sun, moon, and earth into each of the 8 moon phases. So you're going to find each phase of the moon. You're going to record the date that it says it is happening. You're going to need that for step 8. You're going to use your screen capture tool to take a top-down picture of each moon phase. So that is a picture like this, where you're looking down on it. Save the picture to your computer. You're going to upload that picture onto a Google slide that matches that phase of the moon. So you'll title each slide with a date and a phase of the moon, and then you'll upload your picture to it. Once you've saved everything, you'll need to make sure that you go in and delete them off of your Chromebook's hard drive so they're not taking up memory, or you won't be able to use your Chromebook very effectively for after a little bit. So write the date for each moon phase as the title. Also put the moon phase on there. Add a text box to explain what's going on in your image. So here's an example of a slide. So they've titled it the date from here. They've given it the title of what phase it's in. And then they've given an explanation of where everything is in relation to each other. So why is that phase showing up at this time? You will do one of these slides for every phase of the moon, waxing and waning. So you'll have 8 content slides plus your title slide with your name on it. Once you're done, you will scroll down to the bottom. Let me go back into student view here. You'll click on the Google Assignments tab. You should have this saved as a Google Slides presentation. So Google Assignments, click your drive, go in, find your presentation, attach it, and submit your assignment. It is worth 40 points because it is quite a bit of work. And it is due Friday, September 24th. So let's go back into the assignment page so I can show you. Nope, that's not it. Moon phase hunt. How to use this website. So go ahead and open up your Google Doc, your Google Slides, and get that set up with your name on the title slide, and then get your other 8 slides open. So all you have to do is copy and paste it into them. So your first slide, you'll come in here, click on the simulator. It's going to take it a minute to load this first time, so be patient with it. You're going to click View on the top left of the time simulator. That's down at the bottom of the screen. You're going to choose the Earth, Moon, Sun view, and then drag the simulation around to view it from different angles. Begin the simulation. Keep adjusting the time as needed so you can find each phase. So let's click Enter. We're going to go to View right down here, the bottom middle. We're going to go Earth, Moon, Sun so we can see all 3. So this is our straight on view. If you click on this and hold, you can pull it down to do a top-down view. This is the view you need to take for your images for your presentation. You can view it from any angle you want to, from any side you want to, spin it around, view it as you please. Down here is where you're going to get your date from. So it's currently set to August 21st of 2017. So we're going to run the simulation, and I'm going to speed up my time over here so that we can see it moving. So that's every 7 days, so let's not go that fast. So let's come over here. And let's run it until we get the moon going. We want the moon to be in front of us. Goodness. There we go. So right here, we're going to take a look and see what phase the moon is in. I can zoom in. I'm going to close that window. I can zoom in, and you can kind of see how much of the moon is lit up. So if it's off to that side, we've got a top-down view. This is 12 o'clock, 9 o'clock. So 12 and 9, so this is going to be about 10:30-ish. So let's go a little bit further to about 10 o'clock. So what phase is that going to be in? Screenshot this and insert it into your document. Down here at the bottom, you have your example. So this is what each slide should look like. So go ahead and turn the video off. You can rewatch the tutorial on how to use this if you need to, but it's a matter of just pushing play, recording when the moon is going to be at the different positions. So here the moon is in a direct line. So this is 12 o'clock over here, 3 o'clock, okay, 9 o'clock. So when you're looking at your moon phases, there we go. You've got the sun coming over here. The moon is directly in a line across from it. So that should be a full moon. So if you look at it, if you were to zoom in on this and turn your view around, there we go. That's what I'm trying to do. Turn your view around, you should be able to see that that whole side of the moon is lit up. Okay? So work on this, get your slides done, turn this in by attaching your presentation through the Google Drive tab, and you are done for the day. We'll see you next time.